Assalamualaikum and hello everyone. We from class MAT112 G17 group 5. Today we're gonna learn about compound interest and annuity. This presentation will be presented by me, Muhammad Anam Shah bin Shahrudin. My ID student is 2023856878. And my fellow friend Rahman bin Amir, his ID student 2023469664. And my another friend, Lionel Ginori, his ID student is 2023463214. First, let's take a look about compound interest. Compound interest is the addition of the interest to the principal amount loan or deposit, meaning that the interest you earn each year is added to your principal. So the computation of the interest is based on the interest. So let's take a look at the question 1.
Assalamualaikum, my name is Rahman bin Amir. My student ID is 2023469664. Okay, let's move for the answer. Question 1, Roman 1. Determine the accumulated amount at the end of the investment period. Firstly, we calculate the total accumulated amount for the first 2 years. In this case, we use a formula compounded interest, which is S equal P open bracket 1 plus K over M closing bracket power of MT. So S equals 600 open bracket 1 plus yearly rate is 0.07 over 2 closing bracket power of open bracket again 2 times 2 closing bracket. So total accumulated amount for the first 2 years is S equal RM 688.51. Next, for remaining 3 years 6 months, in this situation we use same formula again, which is S equal P open bracket 1 plus K over M closing bracket power of MT. So S equal principal amount, we enter a number from total accumulated amount for the first 2 years, which is 688.51 open bracket 1 plus 0.09 over 4 closing bracket power of open bracket again 4 times 3.5 for remaining 3 years closing bracket. So the total accumulated amount for remaining 3 years 6 months is RM 940.15. And we calculate the total accumulated amount for the end of investment. In this case, we use a formula S equal S1 plus S2. In this formula, S is a total accumulated amount, S1 is total accumulated amount for the first 2 years, S2 is total accumulated amount for the remaining 3 years 6 months. So next, S equals 688.51 plus 940.15. So the total accumulated amount for the end of investment is S equal RM 1628.66 cent. Okay, let's move for the question 1, Roman 2. Calculate the interest earned at the end of the investment period. In this situation, we use a formula I equals S minus P. I is interest earned, S is total accumulated amount, and lastly P is the principal amount. So next, I equal 1628.66 minus 600. So the interest earned at the end of the investment period is I equals RM 1028.66 cent. That's all from me.
Let's take a look at the question number 2. To start a business, society has taken loan of RMZ at a rate 70.5% compounded every 2 months. After 2 years, society has to pay 99,000. Find the value of RMZ. So we know S equal to 99,000, P equals to Z, T equals to 2, K equals to 70.5%, M equals to 6. After that, we put all the information we know to the formula, like in the first Roman. After calculate all the equation, we will get the answer, like in the second Roman, 99,000 equals to 1.160754118p. And we need to move P to the left side and 99,000 to the right side, like in the third Roman. P equals to 99,000 divided by 1.160754118. And the final answer we will get P equals to RM85289.35. That's the answer for this question.
Annuity is a series of equal payment made at equal intervals of time. For example, mortgage payment, installment payment on automobiles, and interest payment on money invested. Annuities can be classified into many classes: annuity deal, annuity certain, general annuity, perpetuity, and others. In this chapter, our main discussion shall be on ordinary annuity certain, where the payments are made at the end of the payment period, and the interest and payment period are of the same interval.
Let's take a look at the question number 3. A baby bank of a personal loan of 50,000 and a customer has to pay equal monthly payment for 7 years at an interest rate of 3.5% compounded monthly. First question, find the monthly payment for the loan. The second question, determine the total interest charge for the loan. Third question, calculate the outstanding balance if the customer decided to settle the loan immediately after 50 payment. Fourth question, calculate the amount that the customer has to pay on the fifth payment if the customer fails to pay the first 4 monthly payment in order to settle the outstanding areas. Let's do this. First, we're gonna use a present value of annuity for the formula for question 3 installment. A equals to R, opening bracket, 1 minus, opening bracket, 1 plus I, closing bracket, to the power of negative n, divided by I, closing bracket. A equals to present value, R for period of payment, I compounding interest rate, N equals to number of payment. The answer for the question 3, first installment, find the monthly payment from the loan. We know A equals to 50,000, R equals to unknown, I equals to 0.035 over 12, negative N equals to negative 12 times 7. And all that information we took in the formula, and we will get like the first installment. Look, after that we calculate off the equation, we will get in the second one 50,000 equals to 74.40558857 R. After that, in the third one, we will make R go to the left side, 50,000 to the right side, and we will get R equals to 50,000 divided by 74.40558857. So we will get the final answer, R equals to 671.99. That's the monthly payment for the loan. For the answer for question 3, second one, determine the total interest charge for the loan. We need to use formula I equals to NR minus A. I equals to open bracket 12 times 7 closing bracket times 671.99 closing bracket minus 50,000. After times, we will get I equals to 56,447.99 equals to minus 50,000, and the final answer we will get is I equals to 6,447.99. That's the total interest charge we will get. The answer from question 3, third element, calculate the outstanding balance if the customer decided to settle the loan immediately after the 50 payment. First, we need to 12 times 7 minus 50 equals to 34, because it say after the 50 payment. And we put all the formula we know to the in the first element. After we calculate all the equation, look at the second moment. A equals to 671.99, opening bracket 32.32371985 closing bracket. So after we times it, look at the third element. That's the final answer. A equals to 21,721.22. That's the answer. The answer for the question 3, 4 element, calculate the amount that the customer has to pay the fifth payment if the customer fails to pay the first 4 monthly payment in order to settle the outstanding area. We're gonna use a future value. This is the formula we're gonna use. S equals to unknown, R equals to 671.99, I equals to 0.035 over 12, and equals to 5. And the answer for question 3, Roman 4, after that we get all the information, we took all the information to the formula, like in the first Roman. After we calculate all the equation, we will get like in the second Roman, S equal to 671.99. Opening bracket 5.029251771 closing bracket. So the final answer we will get is S equal to 3379.61.
Assalamualaikum, my name is Lionel Ginoli. My student ID is 2023463214. Question number 4. Sabrina borrows RM10,000 at 4.8 compounded monthly. She decided to make monthly payment of 250. How long will it take her to pay off the loan? Give your answers in months and round it to the nearest whole number of months. By using the present value method, insert the amount from the question into the formula. By using simple algebra, after getting the amount of negative 0.16 equals to 1.004 power of negative 12t, by using log, we can get the amount of t. After getting the amount of t, which is 3.639622123, or 4 after being rounded to the nearest whole number t, times it with 12 months to get the exact month for her to pay off the loan. That's all from me. Thank you.
Thanks for watching this presentation. Like, comment, share, and subscribe if you like it. Goodbye.